So, thanks again. I'm happy to be here again. I loved being here last year, and I was praying to be accepted as a speaker again. So, thank you very much. And also, thank you for being here. This is more or less related to what I talked about last year. The subject was then the naked bundle. I changed some ideas, and well, this is again about framework decoupling, but it's more or less not fighting frameworks, but more like embracing frameworks in the right places in your application. So it's going to be about this nice little shape. Well, you will learn all about it, of course, but it's just as a teaser for what this is about. You might ask yourself, architecture, and I mean the title of this talk is Hexagonal Architecture. You might be wondering what's wrong with any kind of other architecture. Why do I need to have a hexagonal architecture? Well, so let me answer the problem, or answer this question by explaining the problem with what's going on in application development these days a lot. So first of all, we start out working on a nice application. It's still pretty small. You may be the only one working on it, and you have some great ideas on how to structure this thing. But then people come into your team, and maybe you leave your team. There may be different ideas in the same application. And suddenly, well, people start pulling in extra dependencies, calling all kinds of things, using all kinds of new interesting servers or services next to your application. And then it becomes something like this. What was a nice app becomes a pretty sad app. And that's because of all the dependencies, all the arrows going in any kind of direction. So people usually start to find some ordering principle, right? So you can't make sense of this anymore. So you need some guidelines for structuring your application. And usually there are three ways in which people structure their code. They put things together that are more or less alike in function, basically. So we put things related to the domain model inside a directory called model, or if you use doctrine, entities, right? And then you put everything related to views, like templates or maybe assets, in some directory called views, possibly. And what's left is the C, of course, for controllers. Everything that looks like a controller or behaves like a controller, you put in the same directory. So first of all, there are so many other things that wouldn't fit into this model. But I guess in general, you could say that this is mainly insufficient to serve as an architectural design principle for your application. So I'd say MVC, well, not really, quite sufficient as a guideline for designing your applications. But where does all this MVC thinking come from? Well, basically from all the frameworks out there. And this is not to say that frameworks are a bad thing, just as I said before. They're good in particular areas of your application. But again, well, MVC is more or less coupling to a framework, as in you take their approach to software development as the way to go for your own project as well. This is very apparent if you look at the way that people approach creating projects or starting new projects. So what do? You pick a framework, basically. You install some GitHub repository or create a project, install a skeleton project maybe, then remove all the stuff that is not relevant to your project, the demo stuff or the boilerplate configuration that you don't need. Then you start auto-generating stuff like entities or controllers or I don't know, anything you can auto-generate, and then you're done. You can quickly develop some application, and some people will be happy about it. And then you say, well, we're working on a Symfony project, for example, but it might as well be a Laravel project or any project at all. To me, that's actually outside in. You could say that all of these choices about, well, the framework or the particular type of database that you're going to use or the messaging server that you like, this is pretty much boring stuff. What's interesting is hidden a little bit deeper in your application. So I will show you what that is, but for now, I'll leave it at this. Starting with all the technological choices and, or in fact, determining your technology stack for the project brings you a lot of slow tests, and this is actually very nice. Kieran talked about this this morning, where if you test the application, you will notice that you need all kinds of other things to be available while running the tests. Like the database or a file system. There has to be some directories, there has to be some files. Maybe you even need to have an actual running message server or a message queue. things like that. So setting all these things up is slow. Talking to all these things is slow as well. So your test suite is likely to become minutes, maybe even hours. I hope not. But the question may arise, why do frameworks not solve this for us? Well, it's because they can't. And this is something, well, I mean, we can fight frameworks, or at least I did in the past, but I stopped doing this because, well, I was blaming them for the wrong kind of issues. Because frameworks are all about encapsulation. Just like Symfony and Doctrine, they all try to hide some low-level details from our side. So we don't have to worry about those things. We don't have to remember how to do these things. We just learned from Benjamin that it's not really true. You always have to know about the details behind what's going on and those nice APIs. But then again, you can compare the code like this to get the request body of an HTTP request, find out the content type of the request, and then decode it somehow. All this low-level detail stuff is nowadays wrapped behind all these nice higher-level interfaces like serialize or deserialize, and then there's a request object. You can ask the content type right away. You don't need to handle all those details anymore. And the same goes for talking to our databases. So we used to do things like this. Well, if you didn't use MySQL underscore query functions. But if you use PDO, then something like this would actually fetch data from the database and instantiate some, in this case, patient objects. But this is still quite low level. You can actually see the SQL query, or more or less the one that will be sent to the server. And you need to remember all those steps, like about hydration and the order in which the methods should be called. So libraries like Doctrine, they hide this thing from sight, and they offer you nice little fluent functions as well to do the same thing, but not to worry about all those details anymore. But that is encapsulation. And what's missing is abstraction. We need this to structure our applications in a better way. Because looking at the same example again, all these things are very concrete still. They are words coming from the language in which we speak about databases and talking to databases. So that is why this is concrete, and the code is still about communicating with the database. It's about queries, it's about matching fields, getting the actual query and getting the result from that. What is more abstract would be to zoom out a bit and look at the database maybe as a collection of objects. So then we have invented the word repository to represent a collection of, in this case, patient objects. And we can just ask it for all the anonymous patients. And suddenly we are not in the language of talking to databases anymore. So this is true abstraction. We don't see anything about what's going on under the hood anymore. But the thing is, frameworks cannot offer us this. We have to do this ourselves. Because, well, the framework doesn't know what kind of abstractions you are going to achieve. So you have to do a lot of this type of work yourself. So this was a little bit of a sidestep to explain why the frameworks are not to blame for this. The frameworks are to blame for some other things, which is a lot of coupling to delivery mechanisms. We've seen a lot of code like this. Well, this uses the domain of patients in a hospital, and you want to register them when they arrive. But the problem here is it is very crucial to your application and very crucial to your clients that it's possible to register patients. But this might happen in any way. So it's not necessarily the web. Maybe there is some sort of a machine in the hallway of the hospital where a patient can register themselves, or maybe there is a terminal application that it can be used by some more tech-savvy people who can register clients or patients on the command line. You know, any option there. Still, this very crucial functionality is tied to the delivery mechanism called the web. And you can see this by looking at what kind of objects have been used. The request object and forms are very web-specific things. Also on the other end, there are, in this piece of code, the entity manager, which is definitely oriented towards relational database management. So that is another type of coupling where it is well, seemingly impossible to store the new patient data in any other place than a relational database. So that is coupling to the delivery mechanisms. Then there is a reusability problem. This is not about code reuse and making packages for it, but it's about reusing the same functionality within the same application. So for example, if you have that controller that I just showed you, you can exercise that functionality from the web. You can call a URL or make some request, and that code will execute. But you cannot run the same code from the command line easily, so because the controller code is actually coupled to the request object and the form by Symfony, which are not it doesn't really make sense to do the same thing if you're working on the command line. So definitely not reusable. If you want to do this, and I'm sure you will recognize this, well, you have to find some way to put this code or put it somewhere else. The same goes for running the same code in a loop. You cannot easily run that code in the controller, well, in a loop if you have some batch import script. Well, probably because there is the same issue of being coupled to the web delivery mechanism. But also you'd have to create new request objects, which doesn't really make sense since you're just serving one request usually. So no repeating there. It's just a one-time execution. And then the biggest mistake of writing this very important functionality for your application inside a controller would be that there is a lack of intention. Basically, you can write this down in a diagram like this. It's just data being copied from layer to layer to layer. You can easily see this in this type of code. We have the HTTP request data. We copy the data from that object, use the form to copy the data even further to an entity, and then copy the data again, just as it was provided, to the database. And why I'm saying there's a lack of intention in this code, well, we don't know why this change occurred in the first place. So we don't know what the intention was of the user who first submitted this form, or in fact who made this request. Which fields have been changed, and why did this happen? Did someone make a mistake, or is the change somehow relevant to something that happened in the world outside, or something that is important to the business? Well, this is of course traditional CRUD. And what I think the frameworks can be blamed for is to just say that this is the right way to use the framework. And well, it's one way to use the framework, right? And usually, in my opinion, if you skip the intention of the user, then you might call that rapid application development. So you're just trying to create an application with just a very minimal amount of work and delivering it in order to allow people to enter data in your application and to store it. It's just more or less like sort of a very luxurious Excel file, right? And to me, in many projects, this is actually bad application development, which is a recursive acronym. So you might think about this for a minute there. So in summary, we can say that there is coupling to a framework, but not necessarily to the framework itself, but more to its approach to software development. And it tells us to apply a certain structure to our code that isn't the best that we can have. Then there's coupling to the delivery mechanism, for example, the web. But the same goes for console commands. If you write a Symfony console command, then the code in there is usually highly coupled to the console itself. And then you cannot use the same functionality from the web. Of course, all of this leads to slow tests. You have to instantiate all kinds of things to be able to run tests at all. And a lot of lack of intention in the code. So we don't know why some piece of functionality has been called. It's just copying data to different layers. So in order to find a better way to approach our architecture, let's take a look at what is, in fact, the essence of our application. Well, this is the essence of your application. I mean, just take this as a note. This is what your essence looks like. There's the essence, and there are other things. You could say the world outside of your application. The essence, you can also call the essence the core of your application. And some people also call it the heart of the application. So it's starting to become a little bit poetic here. And the heart may remind you of some subtitle of this very famous book, Domain-Driven Design. The subtitle is Tackling Complexity in the Heart of Software. And this is exactly the same heart that I'm talking about, the essence, the core. A quote from the introduction of this book: "The heart of software is its ability to solve domain-related problems for its users. All other features of software, vital though they may be, support this basic purpose." right? So this is something to keep in mind while I'm just going to tell you the following things. So it's really about solving domain-related problems for the users, right? It's not about picking the right framework or choosing some persistent library. Or it's about that. You solve a particular problem of your client, possibly, but more in general of your users. In terms of code, what's essential in this way is your domain model, and then possibly the interactions that you can have with your domain model. And together, these constitute use cases of your application. And there are often, I'm missing here. I hope it's not, okay. Sorry. Somehow it's, okay, it's a bit slow. I'll try to use the arrows. So together, domain model and the ways you can interact with all your domain objects constitutes your application's use cases. And so what's not essential, you already saw the slide, any kind of technology you pick which is surrounding your application. So as the cool software architect tells us, the database is just an implementation detail. Just say that sometimes at the office. All of these surrounding things, like the technical things, the core doesn't need to know about it at all. So your domain model should have nothing to do with the database that's going to be used for persisting the data, as an example. But at some point, people actually want to interact with your application. So there may be a domain model and there may be use cases defined for that domain model. But there is no web integration or no console integration. So you have to provide some way in which users can actually execute some code, basically, in your application. You can do so, and of course you should do so, except the core doesn't need to know about any of that. And how can we achieve something like that? So we have to distinguish, again, the core and the world outside, everything that's out there, people who want to interact with the application. And we just wrap the core in an infrastructure layer. That's just a name we can pick, and it may make things easier to remember or understand. So for example, we can have some code in that layer which is related to communicating with a web browser or any kind of HTTP client. There may be some code in there which is able to help the application communicate with command line interface users. Same for messaging, like a messaging server, or a database, or the file system, which is a very concrete thing your application can talk to. Or maybe it sends some emails, and that is, again, some very concrete thing, a way in which your application, your core, actually makes itself known to the world outside. I call this maybe accidentally a layer, and that's true. It's a good word to use, layers, in this approach, because, well, that's so nice, layers. Because layers have several interesting properties. They allow you to separate things. Well, maybe that's pretty obvious, but that comes with a great advantage. If you're walking around with something and you don't know, like some piece of code, and you don't know where to put it, then layers allow you to make that decision. Layers often come with some sort of a description saying this kind of thing belongs in this layer. And then you know where to put that thing. So your hands are empty again. That's really nice. And your head as well, of course. So layers have boundaries. Well, that's another obvious thing. But because they have boundaries, you can define rules for crossing those boundaries. So you can determine what things can cross the boundary between layers and in which way. So that's basically about communication. And you can say, we can cross the boundary between these layers in that direction, but not the other way around. So that's one thing you can do with layers. And, well, when it's about communication, it's actually about dependencies, because when you want to communicate to another layer, you have to know the type of things that are inside that layer, like classes or maybe function arguments. And that is about dependencies, of course. So Robert Martin, in his article "Screaming Architecture," which which explains about, well, his idea of the clean architecture, which is very much like hexagonal architecture, he introduces the dependency rule, which is one of those rules for things crossing layer boundaries. And the rule is you can only have dependencies going inwards if you have this layered architecture. Or dependencies on things in the same layer, of course, but you can never point back. So if you're in the inner circle of this diagram, you can never have a dependency on something that is in an outer circle. So what's allowed in any way to cross those boundaries? Those are messages. Hence the subtitle of this talk: message-oriented software architecture, which also sounds very intelligent. That's why I chose it. Messages. And this may sound like a bit like come like a surprise, maybe. Messages can be seen as simply function calls in general. So whenever you have a function, you can call that, and you provide some arguments for it. And that makes it really send a message to another object, or, well, a standalone function maybe. Because the function itself is more or less the type of the message, and the arguments will be the value of the message, or the contents of the message. If you remodel this using classes, you can say that a message would be an object of a certain type, where that is the type of the message, and any of the values you provide as constructor arguments can be considered the contents of that message. And then you just hand it over to whatever function can handle that message, can process the message. And, well, you're basically sending messages again. So you can pick either of these design styles, but we'll zoom in a little bit on the object style. What about the application boundary itself? So we talked about communication between layers. Eventually, there has to be a point where messages can cross the application boundary itself. And yes, that's entirely possible. But how does this work? Your application in some way has to expose ways in which other people or other systems can talk to your application. And if you work with Symfony or any of the framework out there, you know that you just have to define a route. And that is one way to expose, so to say, an input port for your application. This can also be console commands, which is also the case with Symfony applications. Introducing or adding a console command to your application means saying, I have this input port for you, you can talk to me through that port. You can be very specific about these ports. You don't have to expose every piece of code in your application. You just say, this is the way you can talk to me, right? The same for WSDL files. Who remembers those things? Oh, well, it's not about remembering, it's just about currently using, probably. There are SOAP APIs, of course, where you can define the methods that you can call on another server. And that is one way of saying, I have this input port, and you can talk to me. And this is where we finally arrive to this nice little six-sided shape. Because we draw applications or architectures like this, like we have this six-sided shape, because every side of this shape represents a particular input port, or more general, a particular port by which the application allows incoming communication, but also by which the application communicates to the outside world. So yeah, there may be incoming messages. Maybe the web is an input port. The terminal is, or the command line interface is an input port. So why 6 sides? Maybe it sounds like a bit mythical or like witchcraft. I don't know, but it's. I think it's about applications having usually more or less 6 ports, or at most, or on average. I don't know exactly. But in practice, this works. So maybe you're a bit disappointed now, but it's just about convenience there. And of course, you can draw these nice little wallpapers of hexagons. And well, this is partly serious, because if you have a landscape of services, or in fact an application always uses other services or servers, then you can draw these types of diagrams and even connect sites, because one application's output port communicates with another application's input port, of course. So, well, you can get some advantage of writing this out and drawing your landscape of services. Each of the ports of your application, input ports as well as output ports, has its own language by which it allows communication. The web port, of course, uses HTTP as a protocol to communicate. And another side which is about messaging, uses AMQP to talk with other services. Zooming in a bit on the web port, you could say that there is an HTTP request coming in, and then several objects within the application are used to translate the request to something that can be used by the core itself. So basically, from within the controller, the request is being analyzed, and a form can be used to translate the request message, the original one, to something that the core can understand. And this translation, that is called adapters. So it's not really about the adapter pattern, it's more about these classes or objects combined are able to translate external messages to internal messages. And this is really where ports and adapters comes from. So this is more or less the alias for hexagonal architecture. It's also a good time to point out that I didn't invent any of this, except for the slide deck, but it's all by Alistair Cockburn, and I guess he didn't really invent all of this, but more or less put a nice name on it. And like everything in this field of expertise, I mean, people keep reinventing the same thing, or thinking about the same thing just at the same time or 10 years later. So in summary, ports allow for communication to happen, both on the input side as on the output side. And adapters translate messages from the world outside to the world inside, or to the core of the application. Just as an example of what can go on in an application if we analyze an HTTP request like this, we can see that it's a plain text message. And, well, some conversion is going on there. So PHP does some work for us. Symfony framework does some work for us. And then finally, we may translate this to a message that we can understand internally. And in this case, I picked the approach of modeling the message as an object. So as you can see, once we have this command object, it's a message that our application can understand without knowing anything about the web anymore. Because, well, one of the nice things is this is a command object. It represents the intention of the user initially. So whenever the user calls our application from the outside, then we know that they want to register themselves as a patient. We just provide all the data we need. A command implies change, which is some interesting thing. Well, we don't know, usually if we map a request to a form to an object, we don't know really if anything changed. So a command makes this explicit. There is some change. And I guess most importantly, the command itself is independent from the delivery mechanism. So there are no details anymore about the web, no mention of forms anymore, no request objects, no console command things. The command is just a standalone object. And it's just a message. There's no functionality in the command itself. It's just a holder of data. If we want to process that command, then we need a command handler, so to say. And, well, sometimes it's just as simple as this. It accepts the command object, it unpacks the data from that object, and, well, in this case, creates a new entity for us and adds it to a patient repository. Usually, if you start doing things like this, commands and command handlers, it's very useful to pick a command bus implementation which stands between the command object and the handlers, because you can hook in the process of actually executing the command. And well, there are different approaches here. You can use Simple Bus, which I created myself. You can use Tactician by the League. I don't know, there are nice alternatives for it. Looking at what's going on, again, it's the request message that's being translated using controller form request, but it's not being, the data is not being copied to an entity anymore. It's being copied into a command object. And there is a command handler, in this case the register patient handler, which processes that command. This happens in what you could call the application layer. And that layer exposes all the use cases of the application, because the domain layer only contains the entities and the value objects and some repositories. But, well, you still have to have some coordinating services there, which you could call application services. And eventually, the register patient handler, in this case, creates the patient entity and also calls the patient repository to add a patient. Just like in this code. Well, the repository, when asked to add the patient, to its collection of patients, uses something like an entity manager, unit of work, well, if it's doctrine style, of course. And finally, at some point, well, an insert query will be issued, and it will be sent to the database. And that looks something like this. So the patient repository uses all these, well, infrastructure-related objects, and finally sends an SQL query to the database. Zooming out a little bit, you can see that the yellow arrow stands for the persistence port, and the adapter consists of, well, in this case, doctrine classes. The orange one may stand for the messaging port, where some other systems can be notified of changes that have happened in the application. Who noticed the mistake in just one slide back?
You skipped right through the middle of application level.
Yes, I will show you the slide again. It's a bit like a trick question because I talked about this with confidence, but then it's wrong, in fact. So yes, what often goes wrong is we violate boundary rules, and you have to be very much aware of this. So this was the slide. And the patient repository, which I put in the core of the application, directly called things like an entity manager, a query builder, or a unit of work, all kinds of things which are in the infrastructure layer. And if you remember the diagram of dependencies for the application and the dependency rule, we can only point inwards. So we can only use things that are in our own layer or in a deeper layer. And this is actually pointing outwards. So the arrow is in the same direction as in one of the previous slides, but that is just a visual problem. So this is actually pointing outward to a layer in which we shouldn't be able to grab anything. So this cannot happen. Sorry. And sorry for misguiding you as well. Just had to do that. So what happens is, well, the register patient handler uses the patient repository, which uses MySQL, in fact, to store data. So this is really the representation of what's actually going on. But then the patient repository, which is very much an infrastructural thing, shouldn't be in the domain model, since as we discussed earlier, the domain model is part of the core, and that is some part of your application that is completely unaware of any of its surroundings. So it shouldn't be bothered by sending SQL queries to a database. It shouldn't be bothered by sending emails or anything that has to do with something that's going on in the real world. So we have to redraw this a bit and move the patient repository to the infrastructure layer, where it should actually be placed in the first place, because it uses MySQL. But then, well, we still have this problem of pointing in the wrong direction. And, well, who knows a trick from programming? Something you already mentioned, I guess, in the previous talk. Sorry?
Interface?
Yes, an interface. We have to introduce an interface, and then we do something like dependency inversion, where the interface can still be part of our domain model, but any concrete implementation which actually talks to a database, we put that in the infrastructure layer. That's really cool, and it's also really simple. I'm always surprised by how simple and cool and efficient, and well, that's just amazing. And I guess this sort of justifies programming as a whole, I guess. So, well, we can discuss this later. This allows us also to solve some issues that we discussed at the beginning of this talk, where I mentioned that we usually end up with a lot of slow tests in our application. And this also refers back to the talk by Kieran, which showed the same solution. Because we can have several alternatives for that possibly very slow MySQL-oriented repository. We can also have an in-memory patient repository, which doesn't do any actual storing to a database, but which just keeps the objects in memory. And so, yes, the objects are lost after the current request, but that's no problem because we are testing the application, and it's not really a problem if the objects are not really persisted. So that allows you to basically change any part of your infrastructure. So you can just exchange a MySQL repository for a MongoDB repository. like you exchange it for an in-memory repository. And this also means that you can even strip the application from its infrastructure layer and still test all your use cases of your application. This is a nice approach. I will show you a link to Konstantin's article about the same approach using Behat and running the same scenario again with different implementations. So that's very useful, and it basically helps you solve this issue of having all these very slow tests. So what you can do is write all these acceptance tests for your application layer, which also calls your domain layer, but then maybe run just a couple of tests again with the entire infrastructure layer, or maybe still just a part of it, but as much as possible. And this is what Robert Martin as well describes as a good software architecture, because it allows decisions to be deferred and delayed. So if you're not sure whether or not you're going to use a relational database or an object database or a document database for your application, or maybe both, or well, in different places, different databases, then well, you don't have to decide. You can develop such a big part of your application without actually making the decision. You can just delay the decision, and you can also change your opinion on it. So you can change one of the adapters for the interface, and there's no problem at all. There's nothing that changes in the core of your application because it doesn't know about it. So that's a really good thing. In conclusion, what do we get from this? So basically a very nice separation of concerns, and also, well, let me just say, there's the core and there's the infrastructure layer. That is the most important division. Well, but there's no rule about the number of layers. You can also have several other layers. In general, I would say having an application layer is a good idea, and then having a domain layer within that layer helps a lot as well. To me, this discovery meant that I fully started embracing the Symfony framework itself in the infrastructure layer. So where I was talking last year about creating naked bundles and removing all kinds of framework-specific things, I'm taking that back. So it's in the infrastructure layer, it's better to just fully embrace any standard that people may have and just start doing things the frameworky way, as long as you put a lot of attention to the quality of your code that is inside the core of your application. So I guess you can see this coming, that I will be here next year and then say that, oh, sorry guys, I'm taking this back. You know, it's hexagonal architecture that is, you shouldn't do that. But no, I think it's just a development of thought processes. Okay, so having these commands and command handlers, it's not really necessary, but it's a good idea because you reintroduce intention in your code. So every command represents a particular intention that a user had when they called your application. And commands are reusable. So we actually fixed this problem of not being able to execute the same code from a web request and from the console command, but also the problem of not being able to repeat the same functionality again. Well, that you can solve it using this approach. And I think very powerful, introducing interfaces and infrastructure implementations, but also stand-ins for those implementations so that you can write fast tests. And well, I mean, architecture is just one thing, and if you choose hexagonal architecture and start going to apply this, this basically opens up many other doors for you, because well, all the cool stuff is up there. It's about domain-driven design. So if you have this core separate from your infrastructure, then you're free to do anything in your core, in your domain layer, whatever you want. Then having no connections at all with your infrastructure layer in the core makes that every piece of the core can be developed using TDD in a very ideal way. Using commands and command handlers is one step towards CQRS, if you like. And being able to switch part of your infrastructure layer so easily, that also leads to a possibility to develop using BDD approaches. And well, if you download the slides at some point, you can click this link, Modeling by Example. It's an article by Everzet, and it shows you this approach of testing your domain or your application services, and then maybe testing some of them using the full user interface experience. So this is the road to happiness, I would say. I'm not sure if there is room for any questions. Is it time already? Oh, the 1 minute. I missed the 1 minute sign. We have 1 minute. Oh, that's great. So there is time for questions then. Yes?
I was wondering, when using commands, how do you manage quite complex commands, like a register patient or something? If they have a big address or something like that, would you stick in a value object that's come from your domain, or would you keep the command just a load of strings and integers?
Yes. The question is, when commands start to become quite complicated, do you introduce things of your domain model, like the value objects you mentioned, in the commands themselves? No, I like to keep commands very raw. So just scalar values, arrays maybe. And then the command handlers take out that raw data and convert the data into value objects themselves, since, well, that's one step deeper in the application. There might be a point where you have to split up commands, maybe, but the one command object doesn't necessarily have to correspond to one user experience. So you can secretly convert, well, the same input to multiple commands, if you like. There are so many options there. Yeah. Does it answer your question?
Yeah, I think so.
Okay. Thank you. Other questions? Right there. No questions. Okay, so then if you have some feedback, please leave a note here. Joined in /14978, please. Thanks for listening, and I hope all your applications will have cool architectures. Thank you.